This is Andrei Kaplun, and the topic for this project is AWS, IoT, and ESP8266. The problem that this project is trying to solve is that the wine bottles are supposed to be stored at a certain temperature and humidity. So we want to measure the temperature and humidity with a sensor that will provide the data for the ESP8266 microchip to process and to upload to AWS IoT service. So the AWS IoT, with the help of other services like SNS and SQS, will alert the user by sending the text message to the cell phone in case the temperature humidity is out of the allowed range. These are the technology that will be used in this project. ESP8266 is the microchip, and you can upload a custom program to it. It has a Wi-Fi capability, which is very useful for IoT projects. We will use Arduino Uno only to upload the code from the PC to the ESP8266. Once the code is loaded here, it will work on its own. There is no need for Arduino. Only the battery will be needed, and of course the sensor. So this is the DHT11. This is a temperature and humidity sensor. It will provide us the data. There is also here the 3.3 volt regulator. This is needed just to make sure that the voltage is not going to exceed 3.3 volts, because otherwise the ESP8266 might get ruined. We plug it into Arduino to 5 volts, so it still will just be 3.3 here. Let me go back. These are the AWS services that will use the IoT. It will accept the data from the ESP8266 in the form of thin shadows, and it will also run the rules to see if the temperature and humidity is too high or too low. So if it is, then the SQS and SNS will be processing this, the messages and sending the text message to the specified cell phone number. So this is the physical part of the project when it's assembled. You can see the sensor is here, and it's feeding the data into ESP8266, and the Arduino is just used for power and to get the program uploaded from the PC, from the computer, using the USB cable here, and into ESP8266. So let me go to the Arduino IDE. This is where the C code will be written. Okay, so here's the code, and it's using some libraries which you would need to install, and so by default the Arduino IDE doesn't support ESP8266, so you need what you need to do is to go to Preferences, and in Additional Boards Manager URLs, enter this URL and click OK. Then what you will see under Tools in Board, in addition to all the Arduino boards, there will be a generic ESP8266 module. So you will select that, and you will see many different options here, and most of them just leave as default. Make sure the port is selected. Okay, and for the DHT11 you will also need to download the library, and as well as for Amazon IoT client. This is the website which you can use to download AWS SDK, and it will have all the libraries that you need to connect to AWS if you have ESP8266. So we initialize ESP8266 client and Amazon IoT client, and we specify the Wi-Fi credentials and the pin. This is the pin that the sensor is connected to ESP, and we initialize it here. Okay, then there's the function to convert. I don't actually for this project convert to Fahrenheit, but it's easy to do. So here's the setup function. This is used as a one-time setup. This runs only one time when the ESP8266 becomes operational, and so this connects to Wi-Fi and also to AWS IoT. And then another function is the loop function, and this code will run in a loop until forever until the ESP8266 while it's running, while it's operational. Okay, so this is actually reads the data from the sensor, and it's converted to char arrays so that we can just construct the think shadow. This is where creating the think shadow, creating this JSON string, and once it's created with this temperature, we call the IoT client and update the shadow, and we wait for 60 seconds, and we run this code again. So every minute the think shadow with the temperature and humidity will be uploaded to AWS. So what we need to do now is just to compile this code. You can see that it compiled. So after it compiled, what we need to do is to upload it to ESP8266. So we just do sketch upload. You can see that it's uploading. It is 100% uploaded. So now we have all the code that we need is stored on ESP8266. We can go to serial monitor, and since we did output to serial, then we should be able to see some output here. Okay, so it's reading the temperature. It's creating this the shadow string, and it sends it to AWS. So let's now look at AWS and see if we got this shadow there. We'll go to AWS IoT registry things. We'll select our thing, and this is the shadow that we just received. So now, since this temperature is too high, we should be able to see the message that the rule is triggered. So let's go to SQS. Select the queue, view messages, start pulling messages. Okay, so I think this is the message. We'll click on more details. And this is the message. So the message is sent, and next thing we will just check the phone, and that message should be arriving on the phone. And this is the message that we just got, and we'll be getting these messages every minute if the temperature stays above our range. If we need to change the rules to set a different range for the temperature and humidity, we can go to AWS IoT to rules and modify our rule. Click on edit, and what we can do, first of all, the attribute, this is what's being sent to the phone. We can just, this is the temperature and humidity, and this is the condition. So if the temperature is less than 10 or temperature is greater than 15, so we can say, you know, if we decide that it's fine to be, you know, 20, then we can just change here and do update. And also the actions, this is what we use to send a message to SNS. So we can edit that or just add another action, and there's really a dozen of things you could do besides sending a text message. This concludes the demo final project with the topic AWS IoT and ESP8266 by Andrei Kaplun.